So here we are still on our topic of surface processes. We're going to focus on stream meanders today. This is on page 45 of your green notebook. Our learning goal is to identify parts of a stream meander, the cut bank and the point bar. Specifically, we're going to focus on the differences in depth, velocity, and erosion at those 2 points. I guess we should start off by talking about what the definition of a meander is before we talk about the velocity, erosion, and depth of a meander. Meanders are just bends or curves in a river. You can see how this river doesn't go straight through this area, but there's lots of bends and curves as it meanders through the area. Again, bends or curves in streams are known as meanders. So definitely in your notes on page 45, get down a definition of a stream meander, that it's a bend or a curve in a stream. Sometimes this can happen on large scale rivers as well as smaller streams. We're going to focus on 3 parts of a meander, and that's the velocity of the meander, the erosion that takes place, as well as the depth of the river as it goes around a meander. Specifically about velocity, we just recently wrote in our notes that the fastest water happens just below the surface in the center of the river. Just below the surface in the center of the river. That's where the fastest velocity is. Remember, there's erosion with the banks of the river, which is going to slow it down on the side. There's erosion with the river bed, which is going to slow it down to the bottom, and friction, as well as going to slow it down with some of the air. So the fastest water velocity happens a little bit below the surface in the center. That's only if the river or stream is moving straight. As soon as we add a meander or a bend or a curve, that's going to change. Here's a picture of Mr. Burke driving to work. And if you're the passenger in his car, you know that you're going to get pushed to the outside. So as the car goes around the turn, you get pushed to the outside. Similar as when you're riding the Music Express at Seabreeze. They even make an announcement. Smaller passengers sit on the inside, larger passengers sit on the outside. Because as you go around the turn, you get pushed to the outside. The same thing happens in a meander. As the water goes around the meander, it's going to get pushed to the outside edge. So if we take a look at our notes again, we see that we have our stream meander here. There's the water flowing this way. The fastest water is always going to be around the outside of the meander or outside of the curve. So here's a meander or curve. Here's the outside of the curve. So if I draw a line that represents the fastest water, that fastest water is going to happen on the outside of the curve. Here the river is going straight, so now my fastest water is in the middle. So we haven't changed that. If the river is moving straight, fastest water is in the middle. But as soon as we come to another curve or another meander, that fastest water is going to be on the outside edge. And then once it goes straight again, down in the middle. So there's our, notice that the fastest water is always on the outside edge of the curve or the meander. Fastest velocity is on the outside, slowest velocity is going to be on the inside. If we look at this meander, it doesn't matter which way the river is flowing, whether the river is flowing from this side, from right to left, or from left to right. Either way, B is on the outside of that meander. A is on the inside of the meander. Fastest water is going to be at letter B because that's the outside of the curve. Because of this, let's now move on to erosion. Because of this, if the water moves faster, it's going to carry larger and more material. We learned this when we used page 6 of the reference tables, that material is going to be eroded more and larger material is eroded when the velocity is greater. So here we see a stream velocity that's faster, maybe 100 centimeters per second. It can move clay, silt, sand, and pebbles. Yet if it's moving just 0.1 centimeters a second, it can move clay and silt, but it's not moving sand or pebbles. So as the river slows down, it's going to deposit that material. As the river speeds up, it erodes that material. So we're going to see erosion At B, where the water's moving the fastest, we're going to see deposition at A, where the water's moving the slowest. Around this meander here, if that's the inside of the meander, we're going to find deposition. The water's moving slow. Since the water's moving slow, it can't move all of the material. And some of that sand or pebbles are going to get deposited here. So we find deposition at the inside of the curve. Where we're going to get erosion over here. This is where it's going to get cut. Since the outside of the meander is where it gets cut, we call the outside of the meander the cut bank. The inside of the meander is called the point bar. You've heard of sandbars before? Well, a sandbar is a deposition of sand. That's exactly what's happening here. So we're pointing, there's the point bar. The cut bank is where we're having erosion. So we're eroding material here, we're depositing material there. The cut bank is where we have the fastest water, so there's erosion. The point bar is where the water is moving slow, so we have deposition there. We can see in this picture, wherever the inside of the meander is, we see deposition. Here's the inside of this meander. You can see all of that sand and silt that's deposited on the inside. As we go around, this is now the cut bank. Material is being eroded away. The inside of the meander is the point bar, and again, we see some more deposition there. Inside deposition, inside the meander, we see deposition. And this is all happening with what we saw before on page 6 of the reference tables, that when the water moves faster, it can erode more material away. If the water's moving slow, it can only erode a little bit of material. So the other material, the sand and pebbles, that's going to get deposited there. In this diagram, you can see the inside of the curve is where all the sand is. That's where the deposition is. That's creating a sandbar. The outside of the curve is erosion. And if you look at those little dots in the river, those are people kayaking down the river, just to give you an idea of scale. Let's talk about depth. If we take material away on the outside of a curve, on the outside of a meander, that means it's going to get deeper. So when we look at this meander, we could see where the inside of the curve is. Here's the inside of the curve. That's our deposition. So that's going to fill up. Notice that there's no water there. The reason the water's not there is because it filled up with material. If we go across, we're going to find that it gets deeper on the outside end. If a river's moving straight, it's going to be the deepest in the middle. But around a curve, it's going to be deeper on the outside end because that's where the erosion is. This makes sense. If you take material away, it's going to be deeper. If you add material, it's going to be more shallow there. Well, let's draw the same cross section in our notes. If we walk from the point bar at A over to B, so we're on land here. So A is on land. If we walk into this river, it's going to be shallow at the point bar, and it's going to get deeper and deeper and deeper. It'll be the deepest where it's moving the fastest, and then we jump back onto the land at B. Let's draw a cross section of what's happening here at A and B. So A we know is on land, B we know is on land. What happens if we look at the side view or a cross section? Remember, we cut right there and look at this from the side. The cross section will be shallow at A, so the water is going to be very shallow here, and it gets deeper and deeper and deeper. It'll be the deepest at B. The cut bank has the deepest water. That's what our cross section would look like as we walk from A to B. The fastest water, remember, is where it's the deepest, just a little below the surface. Fastest water, that red right there, is closer to B than it is to A. because that's where it's moving really fast there. That's where the erosion happens. This material is being taken away. At the point bar, this is where it's going slow. We're going to see material fill up over here. So that's why it's going to be shallow on that side. Here we can see a diagram that shows us a cut bank at location 1. That's where it's going to be the deepest. Finally, the last part of our notes today is because these meanders move around, because the erosion continues to move the meander, sometimes they can get really close to each other and actually break off. You can see here in this diagram that at one point in time, the river used to flow along this path, but it got broken off and then moved over here. Here the water's moving along all the way around. But right here, if we have erosion on the outside of the meander here and erosion on the outside of the meander here, they're going to break through. And when they break through, all of this water is no longer going to be a river. All of that water is going to be a lake. You can see the process happening here. The water did flow around this way, but now it's starting to break through right here. Now the river is just going to flow this way. All of this water is just going to sit and become a lake. We call that lake an oxbow lake. It's a piece of the river that got cut off and is no longer part of the river. You can see an example of one here. And here. This lake used to be part of the river. It got cut off. Now the river flows this way and left this water just sitting there. That is a former part of the river, and now it's part of the lake. The reason we call it an oxbow, well, here's a picture of me and Mr. Burke on our way to school back in the early 80s. When you have a horse pulling a wagon, that horse uses, or that animal is going to use, a yoke. That yoke fits over their shoulders. Now, to keep that yoke in place, notice this piece here that goes under the neck and then back around. We can see the two pieces sticking out right there. That yoke is made up of these pieces, which are called bows. So here's a picture of Mr. Burke. He likes to whittle these during the wintertime. So we see the bow is part of the yoke, and the shape of that bow, which is labeled here as letter C, bow, is the same shape that some of these rivers, when they turn into a lake, form. So we call them an oxbow lake. So here's an example of an oxbow lake. This water used to be part of the river. The river then cut through a different way and then left this water alone to become a lake. You can see in your notes on page 45 how these oxbow lakes form. As the water moves down, the outside of the meander is where the erosion happens. If I look closely here, I'm going to have erosion happening here. That's the outside of the meander. And I'm going to have erosion happening here, which is the outside of the meander. They get to the point where they're so close together that as the water flows, it's going to break through right there. And the water now, instead of flowing around, just flows through there. There's the river. And now we have some water here. That water could stay there for years and years, even though it's not being fed by the river anymore. Or it could dry up within a couple of years and just be a scar there. If we head to the Genesee River, many of us are familiar. There's Lake Ontario. Many of us are familiar with this part of the Genesee River, where it flows into Lake Ontario, and we've probably been here and maybe seen that, and we've walked along the boardwalk. Maybe we saw when the big ships were there. I assume you probably walked along there holding an Abbott's custard. The river goes pretty straight through Rochester. But if we head a little bit further south, and we take a look at where the Genesee River is. There's the Genesee River down around Geneseo, Lakeville. Notice how the Genesee River has lots of meanders, and we can even see an Oxbow Lake, how the river used to flow around this way, but then got cut off, and now we've got an Oxbow Lake. We can see other places where that's kind of dried out now. The river used to flow around this way, but is now dried up. There's the Genesee River as it flows through the Genesee Valley. There are other rivers, such as the mighty Mississippi here in the United States, that show the same thing. So if we head on down to the Mississippi River, where'd you go, Mississippi? There it is. We can see places where the Mississippi River has been winding for years. All of these curved features are places where the Mississippi used to flow. The Mississippi is this dark brown color here, and you can see here this lake, which is an Oxbow Lake. And if we look close, we can see that there are people that live on this Oxbow Lake. And this is a pretty wide lake, too, if we measure from one end to the other. This is just about a half a mile across that lake, and many miles, maybe up to 8 to 10 miles all the way around. It used to be part of the Mississippi River, now an Oxbow Lake. So we've defined what a meander is. It's a bend or a curve in the river. We know the velocity happens at the outside or the cut bank. The velocity is more or happens faster. The river is moving faster at the outside or the cut bank. Erosion happens at that outside where it's going to be deeper, and they can form Oxbow Lakes. There are your notes for page 45.